Okay, solving logarithmic equations. We've got a couple of different cases. The first case is when we have a log equal to another log. So in this first example, we have log base 8 of negative 2x on the left side, log base 8 of x plus 7 on the right side. This is very similar to our exponential equation scenario. As long as the bases are the same on both sides, the only way that this equation is going to be true is if what's inside the logarithm of each logarithm are equal to one another. So that's all we do. We simply set negative 2x equal to x plus 7. And again, just a regular linear equation here. Negative 3x is equal to 7. Divide both sides by negative 3. X is equal to negative 7 over 3. Now, we cannot take the log of a negative number, but in a lot of cases, the negative ends up working out based on what else is inside the log, but you still want to check it. So use that change of base to check this answer. Okay, plugging that into the left side, we get this decimal value. Plugging it into the right side, we should get the same decimal value, and we do. So negative 7 over 3 is confirmed as the answer. Here's another case, log and log. In this case, it's the common log, base 10. It doesn't matter. As long as it's the same log, we set what's inside of each of the logs equal to one another, and we are going to solve for our variable. Now, in this case, we're looking at a quadratic equation because we have our variable k is being squared. So everything has to be on one side. In this case, we're going to move it to the left side. So we've got k squared minus 6k minus 40 is equal to 0. And then we need to factor. How about 4 and 10? Negative 10 plus 4, negative 10 times 4 is negative 40, negative 10 plus 4 is negative 6. So that tells us that positive 10 and negative 4 are possible solutions. Particularly when there are two solutions, you definitely want to check both of those. Because sometimes, or in a lot of cases, one, if not both of them, end up getting thrown out. They are extraneous solutions similar to what we found with our rational equations. 10 checks out, so we're good there. Let's check negative 4. Be careful with that negative 4. You're having to raise it to the second power. So you want to make sure that you put that in parentheses anytime you're raising a negative number to a power. And negative 4 checks out as well. So both of those are solutions. Okay, natural log works the same way. Nothing different here. As long as it's the same log on both sides, you set what's inside equal. Again, here's another quadratic equation. This time I'm going to move it to the right side. 0 is equal to x squared plus 9x plus 20. 4 and 5. X plus 4, x plus 5. So x equals negative 4, negative 5. Definitely want to check them, particularly when they're negative.
Please pardon this interruption. Today, bus 1 does not have a driver for the afternoon. If you are a bus driver on bus 1, please wait at the tables beside the cafeteria. You should have a bus driver around 4 o'clock this afternoon. If you do have an alternate means of getting home, you may do that as well. Thank you.
So look at what happens here when I plug in the negative 4 and I press enter. It says that it's a non-real answer because when I go to that problem, look at what's inside of our logarithm. It's negative 20 plus 16, that's negative 4. You cannot take the log of a negative number. So negative 4 is an extraneous solution. Let's see if negative 5 works, or if it is also extraneous. It works in the left side. Let's make sure that it works in the right side. And it does. We get this number left and right. So negative 5 is our only solution here. Negative 4 is extraneous. So you must check your solutions just like you had to with rational equations. All right, one more just to make sure that we've got it. Log base 12 on both sides, so we're good. Set what's inside the logs equal another quadratic. So let's move everything to the side with the quadratic term. So 0 is equal to x squared minus 4x minus 21. So that should be x minus 7 times x plus 3. So we get positive 7 and negative 3. Don't forget, something that can make this a little bit easier is you can store your answers as x. It can help when you are plugging these in. It's going to just save us a little bit of time, particularly when we have to do change of base here. So there's the left side, here's the right side. That one checks out. 7 is good. I can store negative 3 as x. And then here's a little shortcut. Second enter. That way I don't have to type all that stuff in again. And then I just keep doing that until I get back to the entry that I need. Both of those, the left side equal the right side, so both of those solutions check out. So you need to complete numbers 21 and 27 on your worksheet.